Peter van der Linden, and I'm a technology evangelist with the Immersion Corporation of California. So in this talk, I'll describe our experiences developing a game. This is our agenda. I'll start with a very brief introduction to my employer, Immersion, and then I'll walk through a case study of a recent game app that we designed and produced. I'll tell you about the design, the coding, and the QA for this Android game app. Then I'll finish up by summarizing what we learned from the experience and how that can help you in your Android development work. I'm happy to take important questions as we go along, and I'll also answer questions at the end. So good questions at the end will get one of these plushes. We've got 3 of them, so that I've got room for 3 good questions. And we also have some t-shirts on our booth in the hall upstairs, and I'd invite you to. Oh, Suzanne's brought them here, and she'll be in charge of getting those to you, as long as supplies last. So do you recognize any of these devices? So immersion haptic technology is in every single one of these devices. Haptic is a Greek word meaning related to touch, just like optic means relating to eyesight. So who is Immersion? We're a small company based in San Jose, California, which is very near to San Francisco, that the previous speakers were praising as an excellent place to visit. And I echo those sentiments. So we're a small company, but we have worldwide reach. We have a 20-year track record of working in haptics for several markets, including, most recently, console gaming and mobile devices. We have a large portfolio of patents, and we're a profitable company. So who is still unsure what haptic means? I would ask you, have you played games on the Xbox or PlayStation 3? They use haptics, and they license that from Immersion. Haptics is using touch for output as well as input. So haptics is communicating something to the user through touch. We have a free library that gives very fine control over the vibration motor on an Android device. When something happens in a game, like a shot or a crash or a motor running, a rip, our library can accompany the visuals and sounds with a matching touch event that the user can feel. This makes a game a little more richer, a little more satisfying for the user, and a little more profitable for the app developer. So we are carrying the very successful console gaming experience to mobile devices. Right now, our library is for Android only because Apple doesn't open up access to their vibration motor. To support our library, our free library of tactile effects, we have a free haptic effect preview app for designers to use. You can get it from Google Play Store. If you have Wi-Fi down here today, you can search for haptic effect preview and get this free app. It lets designers sample and experience and plan which tactile effects they want to use. It saves a lot of time in the design process so that tactile effects selection and implementation takes just minutes. There was a case yesterday of a man 2 booths away from us who on the exhibition floor integrated our haptic library into his app. And that was very impressive to see. It took about 30 minutes, and it boosted the usability of the app noticeably. So our library contains 124 pre-designed tactile effects, broken into many categories, from UI button effects to gaming, weapon, and explosion effects, to more subtle effects. The preview app lets you play and choose among the effects in our library. The library lets you add your effect choices into your Android games. So this is our logo and also our mantra. Apps have feelings too. The challenge is, how do we really show feelings in apps? How do we inspire and drive innovation and creation around haptics? Our current preview app is just a series of scrolling lists. That kind of channels the creativity of game designers into the category names that we chose, and it could stifle innovation. For example, we had a list called double click. That makes people think about double clicks in a GUI, leading them to overlook all kinds of other effects that are double clicks too, like shotgun racking, pistol cocking, a ratchet, pencil tapping, locking and unlocking, etc. So the solution for this problem is to get away from a demo app with categories, each containing a scrolling list, like the one some of you are downloading now, and create a new demo app that showcases haptics in a gaming context. And that was the mission I was given. Peter, go out there and create a new demo app that showcases haptics in a gaming context. So let's take a look at the game design. Okay, I'm kidding you. I'm just kidding. I don't think many people enjoy that kind of talk with diagrams like this, which is too bad because you might see a bunch of them here. Let's talk about how to go from a mission statement to a design. And if you're working on a real game, this is the point where you want to generate as many ideas as possible and then kill them. You want to kill the impractical or losing ideas as quickly as possible. While ideas are still on a whiteboard, they are cheap. When they move into artwork and code, the costs rise substantially. So the starting point for me was literally a blank sheet of paper. I had some help. There was a professional art house that would draw things that I wanted them to, and there were a couple of very talented Android developers, just like everybody in this room, and a program manager to help tie all this together. And there was also a set of Immersion stakeholders in Immersion's marketing team, a product manager, the developer relations team. All we needed now was a design. So the classic way of constructing or designing anything with a story is to get the story arc straight first. This is the way stories have been constructed since before there was writing to record them. This is the way movies, opera, TV programs, plays, radio, poems, basically all forms of narrative have been constructed for thousands of years. You get the story arc, then you cast the actors, and this school of thought is called narratology. It's a narration. Computer games are generally not designed that way. The most successful games start with the creation of appealing characters. When I say appealing, I don't mean that you like them necessarily, I mean they appeal to your emotions. Rovio started by designing in detail the angry birds, and then they designed a hated, greedy pig enemy for them. And whatever your characters are, they are then user-tested and the weak ones discarded. You go forward with the successes and only then create a story and a conflict connecting them. This school of thought is called ludology, relating to games. So we didn't quite do it that way because the characters aren't the star of our games, the haptic effects are. And we weren't designing new haptic effects, we were working with an existing palette of the 124 predefined effects in our library. You can design your own haptic effects. We've got a tool called Studio to help with that. But most game developers just find something that works from the predefined 124 existing ready-to-go effects. So we designed our game in several brainstorming sessions with key stakeholders sitting around a table, generating ideas, discarding them. We went through many iterations on this before we landed on the concept of an exploratorium. An exploratorium, a place where you explore, is a fun, interactive science museum in San Francisco. So we're offering the same kind of environment, but for haptics. So this was another part of our design. This is a website called Cheese and Burger. It's one of several websites operated by the Wisconsin Milk Marketing Board to promote the consumption of dairy products. This web page actually has a working Rolodex. When you drag the wheels on either side or the slider, the pages turn up or down just like a real Rolodex. My colleague at the office, Grace, had seen this site and she advocated strongly that a visually appealing Rolodex like this would be a great concept to replace our scrolling lists of effects. And it was a good idea, and it did actually make it all the way through design and implementation and into the finished app. It's a great visual alternative to a scrolling list, and I'll be talking about the code for this later. So the art house that we worked with roughed out a couple of our brainstorming ideas. This is the conveyor belt. The idea is the moving belt would roll all the objects by you on the screen. If you touched an object, it would take you to a screen with just that object where you could manipulate it and feel haptic effects. So the advantage of this is it supports an infinite number of objects. The disadvantage, among the disadvantages, there's no obvious way to fast forward to a specific object, and you can't see the whole collection of them. And note that the art house is talking about category screens here. They've completely missed or forgotten the goal that we want to get away from grouping effects into named categories, like double click. So here was another brainstorming concept, mini games. There's a saying in English that nothing is too hard for the man who does not have to do it. And my French is so inadequate that I did a Google translation on this, which I'll now speak to you, and your laughter will tell me how accurate Google translation is. Rien n'est trop difficile pour l'homme qui n'a pas à le faire. Okay. Oh my God. You guys are awesome. Okay, so I'm going to take that even if the words aren't completely right, I was trying with the accent. So the mini-game concept horrified me. Can anybody think of some problems with a demo app that consists of 7 or 8 mini-games? Anybody? Call out some ideas that might be wrong with this? Okay, awesome. So the gentleman at the front here certainly deserves a plushie, I would say, Suzanne. Yeah, instead of designing one game, we would have to design and code 7 or 8. And right there, that should have tipped me off that the art house had zero knowledge or expertise or even interest in software. So more about that a bit later. So this rough concept is close to what we ended up doing. There are 7 or 8 environments kind of shown in this. This is a representation of a sports hall, and this is a kind of a battleground area. And that's the kind of what we ended up doing. Each of those environments contains 2 or 3 objects to interact with, and when you move or manipulate an object, it plays a corresponding haptic effect. We were still calling the Rolodex a library at this point. Grace hadn't completely got her own way yet. Let me mention here the taxonomy of games. This is a pretty standard list of game genres, and our demo game has halls or rooms that together represent most of these categories. We have a sports hall, a racing hall, a combat hall, and so on. In the sports hall, there are several sport-related scenarios that you, the programmer thinking of using haptics, can interact with. This represents the final design that we settled on. Once you get past the splash screen, the opening screen is a map showing the 9 places you can go by touching the map. There are 7 themed halls, the Rolodex over there, and then the settings page. The Rolodex and settings pages do what they sound like. A setting is something like turn off the splash screen or show, don't show effect names. Okay, who here, just raise your hand if you like to see splash screens in the apps you use. Who likes to see splash screens? Okay, so there's a small number, very small number, small and dwindling number of people who like splash screens. I hate them. I hate them. They just stand in between me and what I'm trying to do. But I had to include a splash screen in this project because of mandates from above. But I made sure, from my boss who's sitting here watching me, I always like that when I give a talk, I made sure that one of the app settings specified how long the splash screen would run, and the range could be set from 3 seconds down to 0 seconds. So that worked out well for everybody. I'm going to say a few words now about how you specify art assets. The art assets are all the graphics for the game. The backgrounds, all the objects in the game, all the animation frames, and so on. The art house has to be told the sizes they should be, and the preferred drawing style, and the pixel density, and so on. And this is incredibly important to get right, as it affects everything that follows, and it's a prerequisite for everything that follows. You can hardly write a line of code until the art format is specified and you have a little bit of art to work with. Now, before we get into that, I'd like to mention that we had a really good QA engineer on the project whose name was Doug. Doug has an incredible eye for detail, and he's very thorough, and when he saw these slides, he could not help himself. He pointed out to me that the artist Van Gogh cut off his left ear, not the right one, and thus the left frame of these glasses should be missing, not the right one. So I was very grateful for that. And this was an example of misplaced model mapping to reality, and I'll say a little bit more about that later. So we knew we wanted our app to run on as many different devices as possible, so we chose to support Froyo, API level 8, and later. In API level 8, screen sizes were classified into 4 buckets, shown here. And screen densities were also classified into 4 different groups. So did that mean that we needed the artwork in each of these 4 screen sizes multiplied by each of the 4 densities? Nobody knows. There's no advice whatever on this at the developer.android.com site. There's nothing on Stack Overflow except questions from many people, including me, and nothing comes up in a Google search. So I'd written in the contract that the art house was to use what they told us was their extensive mobile experience and provide the answer to this, what format the artwork should be produced in and what sizes. Now that plainly wasn't going to happen. But I'd written the same thing into the software contract, and to my surprise, wasn't happening there either. So it's a basic question that must have been solved by every game company already, but no one is sharing the answer. So I will. I'm going to tell you what the answer is, but I'm going to take a couple of slides to get there to work through the process. So this slide illustrates typical screen sizes of the 4 buckets, and it shows the implications of file size for assets of each size. If you choose to keep your art in the 640 by 480, the green rectangle, your art assets will be about 1/10 of the size in the file system of the size of the very big 1920 by 1200 rectangle, but you will have to upscale them to that size. So you win because it takes less to store, but you lose because you're going to have a noticeable degradation in quality. What you're looking for is a good trade-off of size, quality, rescaling time, and image detail. Now, as well as the physical screen size, you've got to consider the usable screen area. That black bar at the bottom of the screen, right here, is called the system bar. It was introduced in Honeycomb, and it replaced the status bar at the top of the screen for earlier releases. So those rectangles the status bar or the system bar, are reserved for things that the system might want to tell you when your app is running, and apps don't generally overwrite those spaces. So a good way to make progress on a tough problem is to make simplifying assumptions. I did that by specifying that our app should take over the entire screen, including the space usually reserved for the status bar, or on Honeycomb and later, the system bar and action bar. We no longer have to worry about the system bar being present or absent, or different heights on different devices. So now, usable screen size is the same as physical screen size, and that's a great simplification. And then the Google breakdown of devices using Play, which you can find at the developer site, helped me finish resolving the issue of specifying art size and resolution, dots per inch. We don't care at all about small screen devices. Developers don't use those. And developers don't use these. And we don't really care about extra large devices because there's so few of them. So really our sweet spot, we should be specifying something in this large category for all our artwork. Vast majority of screens are going to be normal sized, what they call normal sized in HDPI. So that's a 4-inch times 300 dot per inch. It's about a 1200 pixel on the diagonal. So a height and width that gives us 1200 pixels on the diagonal will be good enough. And this was then, therefore, our final art spec. We chose 960 by 720 as the size for the artwork. That gives us a 4:3 aspect ratio. Other reasonable choices could be made, 800 by 600, which is SVGA, 1024 by 768, which is XGA, or 1280 by 768 WXGA. Those would all be good choices. It's a trade-off between file size and art quality on extra large screens, which again are only 4% of devices. The resolution, the dots per inch, turns out to be irrelevant for artwork. It merely says how far apart each pixel is when it's rendered on the screen. For the art, all we care about is how many pixels there are, not how close together they are when rendered on different screens. So DPI is irrelevant here. So given all that, there's one more thing we need to know. How big are the file sizes? So the file sizes for artwork depends on the style, which is an artistic choice. The art house draws a draft called a rough, and it's the equivalent of a code prototype. It lets you see what's supposed to happen. This is the rough for the Speedway Hall. And the rough is to agree or correct the elements that will be in the picture, how they're laid out, what their relation is to each other. And there are several different styles in which the art can be drawn. I asked the art house to show us alternative styles for this Speedway Hall. They were very reluctant to do this until the implementation phase began and the money started flowing again. So the schedule delay that this caused was a very significant problem for us later. But the art house did eventually show us 4 choices for art style. I'm going to show you 2 of those here. The other 2 styles that I'm not going to show you were 3D styles, and their names, or this is what their names should have been. The first one should have been called Ridiculously Overcomplicated and Detailed Style, and the second one should have been called Insanely Overcomplicated and Detailed Style. So when I say 3D styles, I mean that these would clearly be the basis of an OpenGL 3D model. And we knew immediately that bringing OpenGL into this app would be an expensive and unnecessary overkill. So this style is one of the 4 alternatives, and the art house calls this 2D realistic. And this was the style that the art house calls simplified cartoon. I think they were hoping that we would choose one of the high-end styles, maybe even the insanely overcomplicated one. But it turns out there are significant file size costs to these different styles. The simpler art, shown here, and the more uniform colors results in significantly smaller files. The photorealistic sample art at 1920 by 1200 resolution was a 3 megabyte file. The simplified cartoon art in the same size was less than a megabyte. And at our chosen resolution of 960 by 720, it was only half a megabyte. So we knew we were going to have challenges meeting the requirement for Google Play that APKs must be less than 50 megabytes. So choosing the cartoon style gave us significant help here. And once we'd worked this out, choosing that style was a no-brainer. If the art house had understood mobile development, they could have just explained to us at the beginning that style corresponds to size, and you want to get the art in any largest relevant screen size that works for you. They could have explained those two issues at the beginning and saved everyone several weeks of figuring it out. So this is my gift to you, or my guidance to you. This is our final choice, as outlined on this slide. Now, when you write your game, you don't have to waste time figuring all this out from first principles the way we did. You know, I should blog about this. I should really blog about that. My blog is at blog.immersion.com, and I really encourage you to take a look at it if you like. So let's talk about code for a little bit. How many people here develop code for a living? Okay, so I would say the majority of people in the room are developers, so I'm really talking to you here. But I'm just kidding about this diagram. This is really more of the way I kind of tell a story. So we chose 960 by 720 as the size for the artwork, but remember, when you read in an asset file for the screen background, each pixel is going to take 4 bytes of memory, and bitmaps are not compressed the way PNG or JPEG files are. So if you have a 960 by 720 background file that's half a megabyte as a PNG, and you're running on a tablet with, say, a 2000 by 1250 screen, that's a 2.5 megapixel image, which is 10 megabytes of memory for just one background. And you might have 2 or 3 of those in memory at one time if you're not careful. And this is why you see a lot of games with color gradients as backgrounds. So you just got to be kind of alert to these things. So we knew we wanted the app to run on as many devices as possible. Our library is supported from Froyo on, so obviously our new demo app should be. Oh, I'm sorry, question?
Just a quick question. Have you thought of compressing the textures?
Well, the question is, have we thought of compressing the textures? And the answer is we weren't taking the OpenGL approach, and so the textures, which are kind of like a cloth that you drape over a model to give it a 3D appearance, that didn't come into what we were doing here. We're just working at a step removed from that. But yes, excellent question, thank you. And surely worthy of one of these excellent plushes too. Thank you so much, Suzanne, yes. Yes. Yeah, so this question here about API level was really the only no-brainer or easy choice in the project. So I think I love working with Android. You know, it's one of the best technologies to come down the road in recent years, and it means that all my Java knowledge that carries directly in. I don't have to mess around with some crazy variant of C the way I do on iOS. But the one problem that I have with Android is it's extremely poorly documented, and that's never truer than the way you see target SDK version described in books and documents. They all say the same thing. This means the highest API that you've tested your code on, but really that statement completely misses the point. The point is that as Android support for screen sizes, as support for screen sizes matured and changed significantly, Google introduced a lot of new behavior to make the old features work better on new API levels. For example, in API level 13, Google added a screen compatibility mode to help older, non-tablet apps run on tablets. When such an app is detected, Android will add a new button to the system bar, allowing the user to choose whether the app should be magnified at the pixel level, zoomed in, to fill the screen. By setting the target SDK version to 11, where tablets first appeared, you can tell the runtime system, this older app deals correctly with large screens, so don't apply the compatibility zooming kludge. So it's kind of this target SDK version is a kludge to avoid another kludge. And Android is full of these things. And I only say that because I love it. Here's another example. We use a target SDK version of 17, the most current Jelly Bean level. So we're promising the runtime framework, don't do any of the ugly kludges that you think make old apps look less crappy on new hardware. We're promising that our new app works well with all the new hardware and APIs. And we only gave it a very low minimum SDK version so that we will run on the old hardware. In other words, use target SDK version to tell the runtime you're basically fully compliant with the hardware and software at that level, probably because this is a new app. And in contrast, use minimum SDK version to tell the runtime you want to run on crappy old hardware and frameworks down to that level, probably because this is an old app or a new app trying to reach the most devices. So this code is kind of a practical experience showing how you'd write that way. So you do this in a two-step process. This target API pragma at the top tells the compiler, okay, even though I promised I'll run on Froyo, don't complain about any newer code that uses something later than Froyo in this particular method, okay? And the way you avoid that is by this piece of code here that says only execute this if you're running on Gingerbread or newer. And then what this single line here does is that this is in on resume, and it says set the screen orientation according to what the accelerometer is telling you is up. Okay, so what this neat piece of code does is if you turn the device upside down, it will correctly restart the activity so that it's now the right way up. And prior to API level 9, you couldn't do that as directly as this. There was a much longer way of doing it with more code, but this is how you do it right, and it lets you correct the orientation according to what the accelerometer tells you is up. So that's just a kind of a hint there. So everyone says that fragmentation of API levels is a major problem on Android, and yeah, that's true, but there are some great libraries that help you. Google's support library is actually not that well known, but it's a jar file available for every API level from version 4 to version 13, and it's a backport of some of the higher API features to the older levels. It's mostly to do with fragment support, which is where you need it most, but there's some other stuff in there too. I'd also like to call out the 9 Old Androids library, which comes from a very skilled developer called Jake Wharton. It's an open source library that lets you use Honeycomb's new animation on very old API levels. The first animation API, anybody had to use that? It's unremittingly horrible in several respects. It was a quick and dirty kludge in the graphics layer to get this animation on the cheap, and it was disconnected from the rest of the framework. This isn't really a place to give you a fine analysis of it, but version 2 of the animation support was much better, but still very poorly documented. So this 9 Old Androids library lets you use version 2 animation everywhere, and which at least works. So we use both these libraries in our app. Let's talk a little bit about the Rolodex now. The Art House again showed a lack of familiarity with mobile software by proposing custom widgets for the Rolodex. Rolodex is just a dictionary of haptic effects. The real value of this app is to see the effects in context. We don't want to spend a penny, a cent, a sou more than necessary on showing the list of effects. So they lacked the ability to discriminate where to apply the art budget for best results. So the animation in the Rolodex, and I have a picture screen snapshot of that coming up, is just page flipping left to right. Remember that cheeseburger thing that had the pictures of the burgers in the form of a Rolodex? The most obvious candidate for doing that page flipping would be a frame animation with an XML file to name the series of images containing each frame. That doesn't work on large screen devices because a page animation of this type is basically moving the left side of the screen to the right side or the other way around. So you're moving half the bits on the screen at the same time, and large devices, large tablets, don't have the graphic bandwidth to accomplish that. So this is a screen dump of our Rolodex, and we actually animated page turning using Rotate 3D animation example taken directly from the API samples that Google ships and that you can download and make part of your platform. So this demo basically did a full screen page flip. We just updated the logic and layout to turn it into 2 pages instead of 1. And this was a major win through having familiarity with the Google sample code. And that won us back the time lost by the art house. 2 main choices for sound. Okay, let's quickly go through this. You can stream sound through the media player, and that reads the audio bytes from a file or socket, and has a high startup cost, not very flexible, a poorly designed state machine for the different states of playing, and the alternative is to use the sound pool. That preloads brief sound clips into a sound pool, and they can be played immediately. We used both approaches. Where we used sound pool, we found that the OGG format was sometimes much better than the WAV, the WAV format. We never found a case where WAV gave better performance than OGG, so we switched to using OGG exclusively. Question? I got 5 minutes left. Okay, so let's go ahead a little bit and talk about QA and usability testing. So this is a screen recording that shows what happens if you don't do quality assurance. So it's kind of weird. Very weird. And it's been annotated afterwards by somebody else. So this guy is trying to unlock a car, but due to a misplaced model mapping bug, he's not accomplishing that. The car is some yards further down the street. So the perspective changes. So he's even doing up his seatbelt there. So that's the kind of gross bug that you get without proper QA. And we had to change the name because Exploratorium was owned by somebody else. I'm going to play this clip twice because it took me 2 times to get what's going on. So what's going on here is this is really a gigantic phone, and our usual perspective tricks us into not seeing that. So this actually happened during the game coding. We designed some detail, and someone would complain that it didn't make any sense in the real world. What was the story explaining that object? The best objection was from the CEO. So he sent me email. So this is a monkey that's in our demo app. He appears in the arcade, he bounces around, he demonstrates different effects. Bounce effects are common in some action games, like the Sonic range, but something about bonk really annoyed the CEO of the software company so much that he emailed me to propose dropping bonk. So I was very happy that one of our game characters had such a strong emotional reaction, and I promoted bonk to use 3 platforms instead of 2. And we had a whole extra routine planned for bonk, where at the end of this bouncing, his hat would fall to the ground, he'd play a banjo, he'd pick the hat up. That routine was a victim of the delays in throughput by the art house, and so it never made it into the final thing. The reset issue here is about leaving everything in the same start position after the effects have played. This is one of the things you do want to be consistent about. In the factory hall, we wanted to saw a piece of wood. Something gets cut off it. How do you reset that? There are several possibilities. I chose magic. The workpiece, illustrated here, is a magic triangle of the kind invented by Dutch artist M.C. Escher. that shape doesn't exist in the real world. So I can do whatever I like with it. As you can see, our artist had a little trouble drawing the impossible triangle, but he mostly got it. Here's how we solve the reset issue. We just have the cut piece fly back and rejoin the triangle. Now that offended Doug, our QA guy, and he filed a bug on it. But I closed it as will not fix. Saves a lot of time. So let's talk about what we got right and wrong. These are some of the things that we got wrong. Choosing anything by voting is a bad idea. Working with inexperienced people is a bad idea. Allowing the art house to get away with postponing development is a bad idea. In any software project, you want to do things at the earliest possible point, not the latest. Here are some things we got right. The overall design, the choice of software developers, the fact that we did usability testing, and we delivered on time and budget, apart from this talk. And here are the takeaways for you. Choose experienced development partners. Everything is a trade-off. So from quality, delivery date, cost, employee sanity, you can choose no more than 2. Set the expectations for your own management correctly, and that means scoping the project accurately. You can't rush creativity unless you're in a dreadful place, and then you have to get really serious about making people do what it takes to deliver. Coding is only one piece of a success of a project. You know, the artwork is vital for success too. So really, that's everything I have time to show you. I'm happy to take any questions and give t-shirts. You've been a really awesome audience. Please give yourself a round of applause. You guys are great. You guys are really great. There's a question here.
I just had a question about immersion. Does the IP get licensed to the piece of hardware, or is it licensed with the app that's sold, or how does that work?
Okay, so the question is, how do you get your money? You've told me several times that you give this wonderful library away free. What we do is we freely license the library to game developers. You don't have to buy it, and there's no royalties. And then we go to hardware companies like Samsung, Sony, Toshiba, Ericsson, Google, Motorola. There's a whole list of them. And we say, hey, look at all these great games that will play better on your platform if you license our hardware designs for the vibration motor and associated software. And that's a proposition that they can see works. So they write us a big check. We stay in business. You keep using the library. And thank you for a great question. It certainly deserves a t-shirt, Suzanne. I would say, yeah. Oh, even better than a t-shirt. Any other questions? Oh, yes, yes, sir.
So does your library work only on Immersion-enabled systems?
Okay, so the question is, what happens if I run one of my apps on a library from some small vendor that hasn't licensed your design? It works just fine. You just don't get the same crispness. So, and even if you run this on a device with no actuator at all, like one of the really low-cost devices like the Nook or the Kindle that has no vibration motor, it works just fine. You just don't feel anything. So it works exactly the way we would hope and want. Any other questions? Anybody else need a t-shirt? Oh, yes, sir, in the front row. Oh, can I share the slides? Yes, I can. Of course I can, yes. And probably the best way is for me to put the link in a blog post that I promised to write within the next week. How's that? So please, oh, she's saying no. she knows how slow I am. But so blog.immersion.com, and I'll put a link to the slides there, because there is knowledge that's hard won in here, and it's worth being able to take it away. Sir? Okay, so the question is, do we have plugins for Unity, the very popular 3D development game framework? Yes, we do. We recently announced, we've had a plugin for Unity for a long time, and we recently announced plugins for other popular frameworks like the Marmalade game development framework and the Yo-Yo Games Game Maker Studio framework. I'll be talking with Yo-Yo later in the week, so I'll be working on co-promotions with them. So yes, yes we do, thank you. Any other, sir, green t-shirt.
Is it already released, and if it is, do you know how many games use
Okay, so the question is, how many games have now included haptic effects? That number is growing all the time. It's between 600 and 700 that we know about today, including some of the very largest and most popular games, like Grand Theft Auto, Vice City Edition, like Rockstar's Max Payne, like the Handy Games range of games. If you visit our booth, you'll see a selection of these, and you can also play around with our new demo app and try and find bugs that Doug didn't find. Any other questions from any of you guys? Oh, we'll take the last one. Okay, yes. Sir? Well, okay, so the question is, what is the difference that a user will see if their OEM, the maker of their device, has licensed our technology? They just have a slightly more robust and higher quality vibration hardware and software, and it just gives a slightly sharper, like a HD TV gives you a slightly better picture, but you can still watch programs on non-HD TV. So that
Basically, you work with them to enhance their vibrating system inside their hardware.
we do. We have a team of people that work with the OEMs. They all have a suitcase packed, and they're ready to travel on a day's notice to the Far East, where most of the manufacturers are clustered, and their skill set, their talent, their ability is to make the integration work well and be a good result for everyone. So once again, thank you, my friends, and have a great rest of the conference. He comes to the greatest. Hi. Peter.
Guitar. I'm working for a French company that develops apps for both Android and iOS.
Oh, right.
And you mentioned before